A new giant has taken to the skies over China. It is a mega transport aircraft, a machine built on a massive scale. Many see this plane as a symbol of China's growing power. They claim it could reshape global logistics and military strategy. This new aircraft represents a significant step forward for China's aerospace industry. It is designed to carry immense weight over vast distances. The world is watching to see if this plane will live up to the grand expectations set for it. The central claim is that this aircraft will grant China unprecedented global reach. But such claims often overlook the difficult realities of aviation. Building a single prototype is one thing. Producing a reliable fleet of giant aircraft is another challenge entirely. The first thing you notice about China's new mega transport is its sheer size. The aircraft is built with a wide body and a high wing design. This structure allows for a massive, unobstructed cargo hold inside. The wings are long and swept back, designed for efficient flight over long distances. Underneath these wings are powerful engines essential for lifting heavy payloads off the ground. The plane also features a complex landing gear system with many wheels. This distributes the aircraft's immense weight, allowing it to operate from a wider variety of airfields, though it still requires long, reinforced runways. The design clearly prioritizes function over form. The tall T-tail keeps the stabilizers out of turbulent air, improving stability when carrying heavy or shifting loads. A key feature is the large rear cargo door. It can open in flight for airdrops or on the ground to form a ramp. This enables rapid loading and unloading of outsized cargo. Items like main battle tanks, helicopters, and construction equipment can be driven directly on and off. The cockpit is modern, with digital displays providing critical flight and systems information. For China's military, this new mega transport is a significant force multiplier. A force multiplier dramatically increases a unit's effectiveness. It lets the PLA rapidly deploy heavy equipment and large troop formations worldwide. It could transport a company of main battle tanks in a single sortie, or an entire battalion of airborne soldiers. This speed and capacity change the strategic calculus. China can respond to a crisis quickly, reinforce an overseas base or project power into a contested region faster than before. Expeditionary forces need constant supplies: food, fuel, ammunition, spare parts. This is logistics. A fleet can create an air bridge, a continuous flow of supplies to sustain distant operations. It also enables quick evacuation of wounded soldiers and rotation of troops. Beyond combat, the aircraft serves oversized cargo markets, energy, construction, manufacturing. These items often move by sea for weeks. This plane can move them in hours, accelerating remote projects. In disasters, a single flight can deliver hospitals, purification systems, heavy equipment, and tons of aid. When discussing mega transports, a few legendary names always come to mind. The Antonov An-225 Maria, the world's largest before its destruction, could carry up to 250 tons. The An-124 Ruslan, still in service, lifts around 150 tons and set the super heavy standard. China's new plane is often compared to the An-124 in size and projected capability. The Lockheed C-5 Galaxy carries about 127 tons, including 2 M1 Abrams, but with high operating costs. The smaller C-17 trades payload for flexibility, operating from shorter, less prepared runways. China seems to aim for a modern, efficient strategic airlifter, leveraging newer materials, advanced avionics, and more fuel-efficient engines. The goal: reliability and lower cost per ton-mile than older Soviet-era designs. It may not surpass every metric, but it adds a new, modern player to a very exclusive heavy-lift club. For military use, it narrows a capability gap long dominated by the United States and Russia. When disaster strikes, roads become impassable, and ports may be damaged. An airlifter that carries heavy machinery and bulk supplies is invaluable. One flight can clear debris, restore power to hospitals, and sustain a town with food and water. Deployed for relief, the aircraft becomes a tool of soft power, building goodwill and ties. The arrival of a massive Chinese plane filled with rescue boats, tents, and medical supplies sends a strong message of support. Economically, it unblocks high-value projects, moving delicate, oversized components inland and on schedule. It creates a niche, high-value market for rapid heavy-haul air freight. Development stimulates high-tech manufacturing, materials science, and electronics, creating skilled jobs and advancing the industrial base. Engine, alloy, and control system advances spill over into other aerospace projects. It is an investment in a nation's industrial and technological future. Developing and manufacturing a megatransport is incredibly expensive. R&D alone can cost tens of billions. Designing the airframe, integrating thousands of systems, and testing on the ground and in flight drive costs skyward. Each aircraft costs hundreds of millions. A meaningful fleet competes with other national priorities. Operations are costly. These aircraft devour jet fuel on long-haul missions. Maintenance on engines, landing gear, and airframe is frequent and meticulous, requiring specialized ground support. The commercial market is small. Most goods travel cheaply by sea or conventional freighters. Only a handful fly outsized cargo. Few airports meet its needs, limiting flexibility and raising the cost to expand the network. The dream of global reach meets the hard reality of runway pavement. Engines are critical. Developing powerful, reliable, fuel-efficient high-bypass turbofans is among aerospace's hardest feats. While progress is real, China has historically lagged leaders like General Electric, Rolls-Royce, and Pratt & Whitney. Early versions may rely on foreign or less mature domestic engines, limiting range, payload, and reliability until better power plants arrive. Modern aircraft are systems of systems: flight controls, avionics, hydraulics, electrical, navigation, must work flawlessly together. Integration flaws can cause performance issues, or, worst case, safety failures. Years of testing are required to match proven platforms. International sales need airworthiness certification from agencies like the FAA and ESA, long, costly, and highly scrutinized. Without approvals, prospects narrow to China and a few friendly nations, limiting exports. Buyers weigh supply chain dependence and politics. Some sales may face diplomatic pressure or sanctions. It's easy to be swept up by images and claims that one plane will alter the global balance of power. But a transport is one tool within a vast apparatus: satellites, ships, planes, ground forces, and doctrine. It moves things between safe places and is vulnerable without air control. Logistics matter, but they don't win on their own. Most cargo flies elsewhere. The outsized niche is small. Success demands lower costs or higher reliability than rivals. China's new megatransport is a genuinely significant achievement and a symbol of rapid technological advancement. It hints at expanding global horizons. It could enhance military reach, speed life-saving aid, and unlock logistical solutions for high-value projects. But immense development and operating costs make it a massive undertaking. Technical hurdles, especially engines, and international certification will take years to overcome. It enters a small niche and must prove reliability and cost-effectiveness against established competitors. Politics will shape where it can be sold and how it's perceived. Its ultimate impact will unfold over the coming decade. Success is not guaranteed. If China masters engines, builds global support, and proves safety and efficiency, it could become a respected strategic airlifter. It could carve out commercial space and aid international relief. Otherwise, it may remain a capable, mostly domestic asset, short of game-changer status.